tilt of the Earth, how it changes every 43,000 years, a cycle of that, or thereabouts, 42,000 years maybe, and the rotation of the poles of the Earth, which has got a period of about 19,000 years. So 130,000 years ago, or thereabouts, they were in a similar position together as they are now. So, and that's when the last interglacial warm period was. These overlaps, if you like. It's a very noisy system, so you can't do it, very simply.
There was a gentleman that I interviewed back in 2004 named Dr. Bonley, and his area is in magnetism. And one of the things that said,
excellent,
he's coming back on next week, he said that the Earth is losing 5% of its magnetic field every 100 years, and that this is actually having an impact on our well-being on many, many systems of the Earth. Do you think that's possible?
Yes, it is possible, definitely possible. You see, this could be related to, there's a lot of other things which change the temperature, but generally speaking, the more charged particles collected by Earth, the warmer it is. And with a weaker magnetic field, the Earth can only capture less particles from the sun because its magnetic cross-section, as you call it, is reduced. So that would be part of a cooling trend. I think the problem with those figures is I don't know how reliable this 5% essentially is, but most people involved appear to be saying it is declining. Anyway, that's for sure.
Do you think that we will experience a reversal of the poles in our lifetime, Piers?
No. Those things happen rarely, but they do happen. That is true. It's very interesting what they do, and that appears to be to do with the internal dynamics of the Earth. So there are complications on just using the sun and the moon to predict these slow changes of ice ages, but it's very clear that those are the fundamental things, and what happens internally is largely secondary, but it is important as well.
I know that there's a distinction between the Gulf Stream and the jet stream, and I want you to explain the distinction for the average person. Yes. They're very distinct.
The Gulf Stream is the current in the sea, which goes basically from around the Caribbean up to Norway, or thereabouts, or certainly bays of the British Isles, and that is a warm, generally speaking, current, and it maintains Britain has been, on average, warmer than other countries of similar latitudes. And the jet stream does shift, going further north sometimes, or not further north other times. And during what was called the Maunder minimum, for example, of low solar activity and very cold weather in the northern hemisphere, the jet stream, I'm getting muddled myself. The Gulf Stream went further south and basically warmed up Spain rather than Britain. And the reason for that are probably something to do with the Earth's rotation rate and some connections with the sun. But leaving that aside, that is what the Gulf Stream does. Now, the jet stream is just the general track of low-pressure systems as they cross America or the Atlantic or Europe. And when you see on a map, you see they put these arrows. That's where basically the low-pressure systems go. And roughly speaking, it's where warmer air from the south is meeting colder air from the north. Now, the shape of the jet stream, i.e. it's a wavy thing that goes round and round the Earth. Now, sometimes it gets stuck in places. It is a sort of more or less fixed pattern. That's not very often. Mostly it's slowly moving all the time, so you get low pressures come and go, and you get higher, warmer bits, colder bits, and so on. And the changes in the jet stream, long-term changes are fundamental to climate change, and the short-term changes are fundamental to weather extremes. And the key thing that we do is essentially predict shifts in the jet stream for many months ahead due to what we estimate solar activity and the magnetic effects of the sun and the earth and the modulation by the moon are going to do.
A lot of people have been turning to you because of your predictions, even with floods. And I heard you speaking in an interview about the lunar cycle and the solar eclipses and their relationship to floods. And I'd like you to explain that to the audience. I thought that was fascinating.
Yes. Well, there are three types of jet stream sort of things in the world. One is the northern hemisphere jet stream, one is the southern hemisphere jet stream, and then there's a related sort of thing in the tropics called the intertropical convergence zone, which isn't quite the same, but it does have patterns in it. Now, what we've noticed is that you will get floods in Australia, for example, when you have the La Nina operating, i.e. it's cold in the East Pacific, and you have lunar eclipses or solar eclipses in a certain pattern, especially because the solar eclipses change from year to year when they happen. And they go around with roughly a 19-year cycle. So this year, this year we had solar eclipses, solar eclipse on the 4th of January, and also a strong La Nina, and that gave us those floods. It doesn't mean it's exact cause and effect, but that is a signal for those floods. And it may well be we'll have a similar enough pattern next year for more floods in Australia. And these patterns, you can look at when there was more La Nina and these particular lunar phases, and you can see the patterns. So you need basically multiples of 19 years going backwards, and you'll find these floods, providing there was also a La Nina, or you'll get it in the year there was and not the year where there was an El Nino. So it means the Australian floods are essentially understandable and to an extent, a large extent, predictable. And the idea that they're driven by mankind is complete, utter nonsense. There's no evidence for that whatsoever.
I never heard that floods were driven by mankind. Really?
Yeah, the Australian government was saying that. They went as far as cancelling some projects to build dams because the global warmers had told them there wasn't going to be any more floods. We were just going to have drought henceforth. You know what happened. A number of people were drowned as a consequence.
I have a question for you that has come up recently, and I've seen it written in a lot of papers and magazines. A lot of people are saying that the reason it's colder is because of global warming. And I don't understand that at all. That's like saying something's black because it's white. It's so cuckoo. What is that line of thinking about?
It is cuckoo, yes. But the line of thinking is that the CO2 has somehow changed the circulation pattern of the world, i.e. the jet stream, okay, and in this instance, that has caused these cold blasts in North America. So it's really all caused by CO2, and on average, more CO2 will make the world warmer because it's a greenhouse gas. Now, we know that is factually nonsense, that more CO2 does not make the world warmer. It's the warmth which drives the CO2 levels. But you see, they have that belief, so therefore they say, oh yes, well, all this global warming process, in fact, is also causing the cold. Well, it's a convenient argument because it means that everything they care to mention could be controlled by CO2. Their problem is, of course, they can predict absolutely nothing, whereas we can predict things using solar activity, which is why they never want to publicise our forecasts. The New York Times, for example, steadfastly ignores everything we say. I mean, we warn them, and we even sent a Twitter to President Obama's Twitter group, if you know he's got one, with large numbers of followers.